I want to look at a more complicated type of integration by substitution. So here's something which we've got some function inside here and we've got some function outside. This is the more complicated thing. Now again, we could expand this out using binomial expansion and then times by the x, but it's a lot of work. Instead, natural substitution would be u equals the thing inside the bracket, 2x plus 4, differentiating, we get du dx is 2, so dx is du over 2. Right, putting all of that in, we've got the integral of, well, we've got an x, I'm just going to leave that for a minute. In fact, let's write it in. This thing over here is u, so we've got u to the power of 5, and then du over 2. Right, the problem here is we've still got an x in there. Unlike the simpler ones, this doesn't cancel out. But what we could do with this equation up here, we could rearrange this for x equals. So this thing, if I take the 4 across, I've got u minus 4 equals 2x. And so x equals u minus 4 all divided by 2. We could substitute that in for this x, and we get it all in terms of u. So this thing here is the integral of that thing, so u minus 4, I'm going to put it in brackets, divided by 2, and we've got another divide by 2. I'm just going to bring them out as a factor of a quarter. And then we've got u to the power of 5 du. What we've done here is we've taken the complicated bit from inside the bracket, which was to the power of 5, and we've moved the complication over into this bit over here. Now the bit which is to the power of 5 is the simple bit, and the more complicated bit is the bit that was just the power of 1. Now, it doesn't look like we've made much progress here, but this is something we can expand out really nicely. We don't have to do integration by, we don't have to do binomial expansion. Expanding this out, we're going to get a quarter integral of, well, u to the 6 minus 4u to the 5 du. And in fact, if we brought that quarter back in, we've got integral of u to the 6 over 4 minus u to the 5 du. That thing there is really nice because they're just powers of u. So what we could do is write that as add 1 to the power, u to the 7, divided by the new power. So we already had a factor of 4, now we've got an extra factor of 7, so we've got 28, minus u to the 6 over 6 plus c. If I wanted, I could do some factorization here. Now, what I'm going to do is I'm going to put the x's back in. Before I do that, I'm just going to do some factorization to make it a bit nicer. That's u to the 6. Should we take one of these out as well? It's got a factor of 2. So we've got u over 14 minus a third plus c. And now when I put the x's back in, it's in a slightly nicer form because it's all factorized. So we've got 2x plus 4 to the 6 over 2. And then we've got 2x plus 4 over 14 minus a third plus c. There's a simplification we could do on some of these as well, but I'm just going to leave it like that. The final form that you put your answer in, often in the exam it says show that. So often it says show that is a particular form. So you're aiming usually for something kind of factorized like this. Right, let's have a go at another one. Okay, we're going to use a similar sort of trick on this one. At the moment, the complication, the plus, like having a plus or a minus is the complicated bit, is on the bottom. Now we can't split this fraction up. What we're going to do is we're going to do a substitution to try and move the complication from the bottom onto the top. So the complicated bit is the denominator, so I'm going to pick u equals x plus 3. So du dx is just 1, and so in this case, just du equals dx, which is nice. This thing over here, we've got the integral of 2x over u du, because dx and du are just the same thing. We need to get rid of that x. Well, I could rearrange this up here. This thing up here is x equals u minus 3. Popping that into here, we've got, well, I've got the factor of 2. I'm going to bring it out of the integral. X is u minus 3 over u du. Now again, we've just moved to complication. We've moved it from the bottom, where is a plus there, up to the top. Again, it doesn't look like we've made much progress, But the glorious thing about this is we can split up the top. This is 2 times the integral of our u over u is just 1 minus 3 over u, which is 3 over u du. Okay, well we can do that integration. Let's do it up here. That is equal to 2 times, let's put up a bracket, 1 integrates to u minus 3, 1 over u, well if you think back to our other function things, that integrates to log u, because 1 over x, we just do it as an aside, 1 over x, the integral of it, is log x. If we want, we'll have those modular signs in, don't worry about them yet. So if I had 3 of these, then I'd get 3 lots of this. Same idea here, it's just a different variable it's used. So we've got 3 of these 1 over u's, so it's going to be 3 log u plus c. Again, this is in terms of u, so if we substitute back in for x, we've got 2u minus 6 log of x plus 3, modular signs, plus c. Oh, I haven't substituted in for the u at the beginning either, so 2 times x plus 6 minus 6 log of that thing. This plus 6 doesn't really matter because we've got a whole plus c at the end anyway, so that it could be absorbed into the constant, but let's just leave it. Done. Here's one for you to have a go at. Okay, here it is. Pause the video and then I'll go through the solution. Okay, solution. We've got u equals x minus 1, du dx equals 1, so just du equals dx. This thing over here, where we've got the bottom is definitely u. The top, if we rearrange this for x equals, we've got x equals u plus 1. So this is u plus 1 du, because dx is just the same as du, which we can split up. U over u is 1 plus 1 over u du. That goes to, well, 1 just goes to u, and then this thing is log u plus c. Substituting in again, we've got x minus 1 plus log of x minus 1 plus c. Once again, this minus 1 doesn't really matter because it could just be absorbed into the constant. Cool.